So, hey, everybody, thanks for showing up. Another America's meeting kicking off on March the 3rd here. So, we've got a couple cool things. Definitely, the big thing here is having Eric kind of giving us an update on ICP and the goings on there. What's the latest and greatest there? But I think what I'd like to do before that is I've asked DeepC to kind of go over something that's been going on within the governance group that we're really trying to get some momentum behind. And I don't think a lot of people have heard about this. So I thought it would be a great opportunity for us to kind of introduce it and kind of talk about what's trying to be accomplished. And DeepC has been kind of leading the charge on this. And so I thought he'd be perfect person to kind of talk about this. And we've got Philo here, who's been real instrumental in helping us kind of assemble the parts to get us to where we are. And then also, Dumb Dave also has been quite forceful on this as well, helping arrange this. So I want to make sure credit goes to where credit is due. So are you ready to kind of just talk a little bit about this, DeepC? JD?
Yeah. Can you guys hear me okay?
Yeah, sound great.
Great. Yeah, glad everyone's here tonight and glad I got asked to help out. My kids might make some noise, so if that happens, I'll just kind of try to bribe them with watching TV. But yeah, to just jump into it. So we've had the governance treasury calls, which has been amazing, especially from Philo and Greg and everyone else. And I've been kind of just lurking because I just been taking care of my kids a lot and making noise, so it's hard to get involved. But I was listening one morning. That right, nice, right? And I could see that there was a lot of interest in going to, we know that if we pretty much know that everyone's going to vote to build, and then after that, the community has to build essentially the DAO, the voting process. How are we going to accept proposals? What's the vision? What kind of proposal? And this is not going to be a fly by night thing. It's going to be a very in depth. It's going to be more in depth than even the current vote, and that's kind of was always sort of the consensus. And in reality, even the current vote for burn or build took almost a year so far. About 8 months.
It's pretty much.
Has it been?
May will be May. April, May is going to be a year.
Yeah. So it just goes to show that when not doing a centralized project management and project development definitely takes longer. However, there's a ton of interest and I think a lot of enthusiasm of, hey, we have these funds, we can see the Iota ecosystem growing at exponential rate, but even faster is the crypto community, and you have these other uh, organizations and tokens and communities that just have this massive war chest from big ICOs or are kind of have centralized whale teams that just kind of make all the decisions. So for Iota kind of, really be able to compete against that. I mean, and one example is, oh shit, what was it? What was like the first original DAO? I forget that token. They were literally like the first one. Max Kaiser had a big bus promoting them.
MakerDAO.
MakerDAO.
You mean
right?
Was it making? Okay. Was that? But so when I started looking into the DAOs, I was so surprised that like 40 to 50% of the DAOs do marketing. The teams vote to just spend money on marketing. And I remember seeing Max Kaiser with whatever it was, thinking, "Oh wow, he must really like this." No, he was just getting paid $250,000 from the DAO, though. So, where Iota I think is much more, yes, it'd be nice to have a little marketing, but we're definitely, as we show, more development side. But again, development takes money. So there's been some people in the group that said, "Hey, how can we just take a portion of that?" Right? So if we got whatever it is, 50 TI or so, can we take 2 TI? Can we take 5 TI? Can we take 10 TI? And if it takes a year to a year and a half to maybe 2 years to build the proper treasury DAO in which it's done in a decentralized way and it's built by the community and then it runs on its own, that's going to be a year and a half that all those funds are sitting there. So we're kind of talking about, is there sort of a bridge, right? Is there something that we can do that can speed up the process? It won't be as good as the final DAO, but it might be a little bit more centralized, but it's going to get money out to the community. And can we do this in a way that the community can back this? So, and my background is I've, come from 4 years in the Marines, and then I got into oil and gas as a deep sea diver, and then I transitioned to subsea inspection project manager, and then topside refinery project manager, and run a department. And so my project management side, I always remember the three things where there's like, when you have a project, you can look at cost, speed of the project, and quality. It's like the three things you want in a project, but you can only get two. You can never get all three. It's almost like the trilemma in a sense. So, the Treasury DAO, we want quality and we want a lower cost, means your schedule is going to take longer. We can't just throw a ton of money at it because we don't have access to the money. What we want to try to do is get some money out there, and even to that extent, we don't necessarily have a huge funding to do that. So we might sacrifice a little bit of the quality, like a nice UX or something like that. But really what that comes down to is we can use the voting process that we already have. And, some of the questions or concerns are like, okay, what would be the quickest way to get projects funded, which would be some sort of delegated teams to at least vet the projects, and or either select the projects or kind of organize those projects so the community can select them, one or the other. And then the second big thing I think that we talked about was, if the community was to back this and support this and say, let's just say, hey, let's release 5TI and we're going to fund 5 projects or 10 projects, whatever. Okay, then how can we do that? How can people submit proposals? What's the structure of the proposal? Then how do we release the funds? Who holds the funds? Well, we already know the IF and the EDF has a process that has worked. They have fixed structured proposals, which companies or organizations have to use. And through that, then they also have third party, what's it called, that they hold the funds and distribute?
Custodians.
Custodian. Yep. So they have the custodian, which is not part of the IF, totally third party, right? And as well as just they've been doing this for 4 years now, or 3 years, whenever it started. So there was discussions of, if the community backs this, on the holding of fund sides, we can use that custodian because they're already used to using Iota, they're already used to working the Tangle, they're already used to working with multi-sig wallets, etc. And then we can have the EDF as more consultants. We can kind of have them guide us in selecting proposals and using theirs. And if anyone's ever seen, if you go onto the EDF and you look at their PDF, all the proposals are the same. What I really like is they break it down into milestones and milestone payments. So the proposals that win, and let's say they get $500,000, their first milestone may be 35,000, and they have to provide those milestone one submittals, and to show that they're actually completing what they're doing. Hold on, buddy. I'm not sure. So I'll try to cut it short because my boy's about to lose it, and I could bribe him with chocolate. But
Okay.
yeah, that's ultimately what we're looking at. But we want to do something only if the community is supporting it. And can we get a consensus to that? People say, yes, hey, this is good. This is going to get some projects going until we get the final Treasury DAO. And yeah, I think it's a great idea. And I think it's going to help the ecosystem. And also, it's going to give us an opportunity to test out things like delegated teams. How do the teams do well? That we could then use like a lessons learned to go into the final Treasury DAO. So
yeah,
that's where we're at, and certainly welcome people to get involved. I think it's a smaller group of the Treasury DAO. I think, again, as people are interested, I'd really like to start jumping on it because I think we can make it happen in a quick time, but we do need to get active. And my view is quick and easy. The Discord voting is a way to get our initial consensus within the community and the Discord community, and then kind of bring that to the broader community and just try to get solidification votes and then just push forward. Hey, we want to do this. What do people think? Let's do this. Okay, boom, get on to the next thing. Let's complete this. So yeah. All right. I'm going to jump off from here.
All right. Hey, thanks so much. I'll just add a little color to that. In the description of what will happen with the IF and the way that this group would potentially work is the IF has agreed to actually work as a service provider in this arrangement, so that the community could and the people that have been nominated by the community to help with managing the proposals and the releasing of funds. What would happen here is the IF would be given instructions by this group that says, please release these funds. They've met these milestones. They would confirm that information, and then the IF would then get the Crypto Finance AG, the custodian, to release the funds to the group, and that's how it'll work in the beginning. But this is a temporary measure, right? This is something that we've had a meeting where the legal and the financial folks at the IF came in and talked with us and discussed the ways that this would happen. And we need to make it clear. The IF is providing a service for the community, and this is a temporary arrangement as we are building out and our DAO organization and our fully working DAO. So it is not to be seen as a permanent structure that need to be separate. The IF can't perform this function for a very long time, nor do they want to, and nor does it is not in the best interest of either party for that to happen. So those are kind of the guidelines and how this would happen if the community comes together and says, hey, let's start funding before we can actually get a formal DAO working. So anybody have any questions on that?
Let me maybe just add a
sure.
comment.
Please
this
do.
kind of is so what would then need to happen would actually in reality would be that the community would need to decide to donate a certain amount of tokens from this 50 TI pot to the EDF entity in Switzerland. So it would then be a purpose-driven donation. Yeah, so there would be something that there would need to be a first vote in Firefly, like a full community vote that asks the community to donate a certain amount of tokens to the Swiss entity of the EDF, with the purpose that these tokens will be spent on an order of a community committee or whatever. And then the EDF or the Swiss entity could accept this and just really be providing this custody solution. Yeah, so they would provide the custody wallet and the connection to Crypto Finance AG, and help with the infrastructure, like JD said, around proposal management, around milestones. We would provide our, let's say, our knowledge and expertise, and then there would be really the community would need to decide which projects, what should happen. We would then kind of also take care of important things like KIC and AML, because still the Swiss entity cannot just give out send funds to somewhere. Yeah. So the receivers would, of course, still need to be KIC'd and stuff like this. But yeah, that's actually a thing. So if this should happen, then it would need to come from the community as a request to the foundation to offer this kind of also legal protection. Because if you see that there would be maybe let's say there's a community committee of 10 people, yeah, they would kind of either decide on themselves or prepare projects to be voted on by the community. Still, those 10 people would need kind of a legal liability protection, and setting something like this up will take a lot of time and cost a lot of money. But the EDF or the Swiss Foundation is already such an entity. So these people that are involved in the core functionality of such a speed funding solution would then be able to be integrated into the Swiss association, or the Swiss Verein, is it called in Switzerland? So they would then actually kind of maybe be written into the legal documents of the Swiss Foundation, maybe for temporary or for like a subsidiary of this Swiss Foundation, and then have the legal protection provided that is needed to act on such a thing. That's very important, I think. Otherwise, anybody involved in something like this could be targeted by whatever. And so this is something that can happen very quick if the community wishes to do this.
And I guess
That's,
the
I
key
think,
thing the key thing here really is that this is something that the community has to drive, and I mean drive. This cannot be Philo, it cannot be the IF, because this is the community's funds, right? So they cannot they cannot be prodding us to, hey, get going. It's not like the DAO, right? To get us to the vote. We have to drive this entire thing. It either happens or doesn't happen because the community members did or did not continue to pursue this in an aggressive fashion, right? So that's really what it comes down to. So that's why JD is going to be great on this, but other people that think that they can help drive this, keep the momentum going, help engage the community, to get us to get consensus, help us select the members that would be on the community if we get that consensus, and then drive the whole process. That's the only way this is going to happen. So we talk about community a lot. This is our perfect opportunity to stand up and actually execute. So I'll just kind of leave it there.
Yeah,
yes.
and I'll say, like I think everyone has done a great job in the Treasury group to get us to now. And I mean, we know that people are going to vote build unless some crazy, out of the world thing happens. And then we got to put the work in, and it's going to be difficult for sure, and definitely will take certain community members that have the time to put in, and two, want to put that time in, and just to know, like, I think people have, when we talked about the bridge fund, was also, this is the bridge in the sense of once the regular Treasury DAO is complete, all the projects transition through the project management side of the DAO at that point. So if they've, on milestone 2, well, to get to 3 and 4 and get payments pen out, then they're just run into the full process at that time. So, but I'd be quite curious if people in this group, because I always like to hear people in different groups of, is that something that they think they would support, like have some sort of, small funds that can ignite some of the ecosystem and support it grow before the final Treasury DAO. So it won't be perfect, and there'll be criticisms, as there always is. But the alternative is, waiting 1.5 years to 2 years to try to make the most perfect thing we can with no criticism.
I'm willing to be, dedicate time to get eggs thrown at me.
No, that's great. And yeah, if anyone does, we have the bridge speed funding channel, and I think
There's also a sign up list, right?
Right. Yeah, I think Holger has a post in that channel that you can click the check mark and then get designated to be in that. And I think it just shows who really wants to be active. And personally, I would like to just start running with it and just start doing votes of how can we, and really, I think something I forgot to say too is we'll hopefully and most likely we'll all vote build. So what are they going to be the next 3-4 votes after that? Like, is it, because we can just, within close that vote out and 2 weeks later get into another one, whatever that is, just to to continue that momentum, because there's definitely going to be a lot of attention on the DAO, on the treasury, on the community and the ecosystem. And I think it's a perfect time to try to, take that fire, Cambrian explosion, and keep it spreading like the NFT craze is going. So looking forward to it.
Yeah, this is Isaiah. I'm in. I like eggs too. So and I'm running out of funds to bootstrap these projects, so I like this idea.
Yeah, I mean, this is actually kind of right. When Adam and I first started working on the voting system, our first proposal to the IF was basically, hey, we figured out that immediately after the vote is for build versus burn, right? And assuming it's for build, the community is going to expect us to be able to run and do something, right? We've already been waiting forever for the money. The money is there, but we still can't touch it, right? So we identified that, and it's come to fruition. I mean, we're about to be there. So now we're able to. We actually have better bearings, and we can get the community to start doing this. And so let's drive this. Join that group. Join the. Put your name on the list. Anybody else? Share the word that we're trying to get out there, because there's going to be a lot of discussion around this from people. Yes, there's optimistic about it and not so optimistic about it. Then we'll want to make sure that this is handled in a way that is fair and meets the needs of the community, and so that'll be there. So the sooner that we can start pushing, the faster we'll be able to plow through all of that, because it's gonna happen. It's just the matter of working with groups and large groups and being decentralized. So we just gotta know that that's coming, and we're just gonna have to work through it like we did for the build versus burn vote. Okay, anybody else have any more comments? Because Eric's been patiently waiting, so I want to be able to get to him. All right. Okay, Eric, how are you doing? Are you ready to give it a go?
Yeah, sure.
Okay.
Let me quickly share my screen. This button. Screens. Go live. Okay.
All right.
So,
switch over to
I'm sure
Eric's
they will
presentation.
switch to the other screen soon.
There we go.
So, right on cue. Let me zoom it a bit for you guys. So, yeah. I got a call from Greg this morning.
Yeah.
He had a cancellation.
Can you bail me out?
Yeah. Hey, Eric. You like to hear yourself talk, so why don't you? So okay, I volunteered. Very quick update first on the ISC, Iota Smart Contracts. We just released a new version in master and develop in the repository that includes a number of things that came out of the Stardust effort and have been backported into that repository. For us, it makes it easier to keep them both in sync a bit, and at least we're talking about mostly the same code with certain things, especially in the WebAssembly area. So there's a new version there for people to play with. For the rest, we're still deep in the Stardust effort. I believe there are some signs that we might have a test net within a few weeks, but I cannot confirm that with a hard date or anything. But that means that the Bee and Hornet teams are doing well. So that means the basic stuff that we need from the smart contract team from the level 1 software, from the Tangle software, is mostly there. On the other hand, the whole smart contract repository, the WASP repository, is quite big with lots and lots of little corners and separate items and test software and whatnot. And we still haven't gotten the entire repository even compiling again. We have a large number of components in the repository that are currently working and working together. We have the entire stack for the Node software with simulated backend, so no real Tangle, but a simulated Tangle, and then the virtual machine with what we have so far in the sandbox that smart contracts are talking to, and on top of that, the EVM is running, and on top of that, the WASM VM that is my responsibility is running. In fact, my end is running so well that I'm going to have to wait for things that I need to add to the sandbox interface once they show up. So on my end, I have gone back to the old software in develop, and I'm currently working on a new incarnation of the client-side software. We had a first incarnation of that, but I had to abort that because of the switch to Stardust. But now that everything is working there, I'm switching back to finish that. And implementing all that Stardust stuff gave me some new insights as well. So I'm also taking the time to make it a kind of a newer incarnation that makes more sense to me, at least. And I'm hoping if I explain a bit about that, it will make some sense to some of you. When Greg asked me to talk, I was thinking, what can I talk about? I said, do you mind if I talk a bit about the WebAssembly stuff? And he was okay with that. So this may be a little bit technical here and there for some of you, but I'm going to try and give a broad overview of how many components there actually are in that, how many moving parts there are that all work together, and how the design keeps that manageable enough so that I, as a single person, am able to keep those balls in the air. So that's why another reason for that was that I was thinking of getting some documentation updated, so I'm going to need some more images. So this was a good point for me to start on those images and see if they work out and if I can tell a story around those images. So I created 3 new images especially for you guys.
Well,
this
they look great so far.
This is the first one. Yeah, I like colors. So so what I'm displaying on the screen is essentially the first stages of the process of getting to smart contracts on Iota smart contract protocol. On the WASM VM, so the WebAssembly VM, everything is now centered around the schema definition file and the schema tool. So initially we were supporting more off-the-cuff programming by others, but since everybody immediately flocked to the schema tool and due to 4 moving insights, I had a few nice brain flashes how I could use the schema tool myself in the libraries and such. That made it now the centerpiece of the entire build stack, essentially. So what we have is as you see on the left side, the nice little box with all the colors and lots of text in it, is what essentially describes the schema definition file. So a smart contract, it operates in a certain way, and you need to be able to define exactly what is there, because you want smart contracts to be able to interact with each other. So the schema definition file is kind of defined for that. You can indicate what is there in your smart contract, what it looks like, how it needs to be called, etc., etc. And that in turn will allow all kinds of tools later to do all kinds of interesting stuff. One of the tools that we already have is the Schema tool, which is used to generate an entire skeleton for a smart contract. It will literally generate code, all the code necessary to implement what is defined in the schema definition file as source code in the desired language, so either Go or Rust or TypeScript. And what will come out of it is literally a contract that adheres to that definition exactly and does absolutely nothing. Because what it gives you is the entire skeleton contract, and the only thing that is left for the user is a smart contract is consisting of a number of functions that work together, and these functions are triggered regularly, and there are few functions where people can inspect data that pertains to the smart contract. And so what exactly those functions do, that is the domain of the user. But to make it as easy as possible for anyone to start, all the rest of the code, that the whole layer that needs to interact with the WebAssembly virtual machine, and the layer that interacts with the sandbox on the WASP node, and everything there is intentionally as much hidden as possible. There's always ways to bypass it. So if absolutely necessary, you can work outside of the framework. But you will find if you use it that it is very easy to use, and it's also providing you with a lot of flexibility, and it will generate code for you that is absolutely bug-free, and that is very, very important. So one of the things that the schema tool allows you to do is on the fly adding definitions, and then you just run the schema tool and it will regenerate all this code, but now so that it mirrors the new schema definition file. So that is very handy. You can completely focus on your own code, and everything else around it will be maintained by the schema tool. So what is in a schema definition file? We have structured data. There is a number of standard data types that you can use. I mean, you have Tangle addresses, or you have accounts as they are defined in the smart contracts, because the smart contracts themselves are keeping track of the tokens that have been sent to the smart contract by assigning them to accounts for the user. So all those accounts are being kept track of. You have things like hashes, or you have a chain that you interact with, so a chain ID. You have all kinds of values you want to store, so you have byte arrays, you have strings, you have all kinds of integer types in different sizes, and signed and unsigned, things like that. And you can use all those what we call concrete types to create structured data. So that is literally what in computer language is a struct, and it has a number of fields, And what the tool will do is it will generate code that will automatically serialize or deserialize such structures to a single byte stream that can be stored in the state storage of the smart contract. Another thing we have are type definitions. On top of the very simple state storage that we have, state storage essentially is a simple key value map. That means that you have a named key, and that specifies the location for a certain value. Every separate value has its own access path to that value that is defined by different keys. So on top of this very simple, well, almost one-dimensional model, I have defined a multi-layered container model. That means that you can have containers like maps and arrays, and in those containers, again, you can have maps or arrays. Currently, we only go 2 levels deep. We just found out that when we were testing that the 3rd level doesn't work yet. That's something for the future. The first 2 levels are definitely enough to do a whole lot of stuff already. So that's on the to-do list to expand on. So we have kind of a virtual method of defining containers, and the containers have an identifier of their own, and the keys of the values in the containers are being constructed along some kind of a path, and that will define at what location in the actual state storage map the value is stored. So we don't have actual maps and arrays as normal programming languages have, but they are virtual, and that gives you a few limitations, but it also it improves a lot on top of the fact that we only have a very simple one-dimensional storage model otherwise. Then what we have is state function definitions. State functions are essentially functions that can modify the state of a contract. They are always signed by someone, and they're always checked that someone has access rights to that function and can actually do those modifications. And those modifications could be like you send some tokens to that function, and then the function will distribute it to the correct people, for example. We also have view functions. View functions are functions that are used by anyone who wants to look into the state of the contract. And you can, for example, read out interest percentages, or how many people have been using this contract, or things like that. And those values are read-only, so they never modify the state, and therefore they can be used by anyone, essentially. Each function has parameters that define some inputs to the function, and they can have results. And so what we have in the schema definition is that we define the parameters and the parameter types and the results and the result types for functions, and that is kind of identical for state functions and for view functions, although of course the view functions can only read the state and not write it. So then we have the schema tool, and the schema tool will take this file and generate code. And to allow easy access for many programmers, we currently provide 3 different programming languages that you can use. We have Go, we have Rust, and we have TypeScript. So the code that's being generated in the language that you desire, and then you add functionality to the skeleton functions that are empty. You add your own functionality, and then you use a specific compiler for that language. And in this case, we use the TinyGo compiler for the Go code. We use wasm-pack, which is part of the Rust build stack, for Rust code, and we use the assembly script compiler to compile TypeScript code. And the result is WebAssembly code. WebAssembly is an exchange format that is gaining a lot of traction on the web, where there used to be a lot of JavaScript code in browsers. You can see people moving to WebAssembly because you can translate WebAssembly directly into the code of the machine it's running on, and therefore it can run immensely fast compared to JavaScript. And since it is designed to run in its own sandbox environment, it means that WebAssembly cannot do anything other than what the system that it runs on allows it to do. So by default, you cannot access files. You don't have access to a randomizer or time functions or the internet or whatnot. That all needs to go through a very specifically defined interface, and that is defined by the host that hosts the WebAssembly program. And this is how we make sure that we have a very secure system where smart contracts cannot access each other's data and not even access the data of the WASP node itself, other than through those interfaces that we have provided. So that is in a quick overview. That one. So this picture will.
Maybe can you ask some?
Sorry.
Do you want to maybe have somebody ask questions like myself?
Oh yeah, sure. If you have questions, go ahead. Go right ahead.
One thing, when I talk to people now, and the question is how do you get started and so on, would you contrast the WebAssembly with the three different development languages with Solidity, EVM?
Yeah, they're separate developments.
Yeah, but like why, like the pros and cons? What do you get here? Like you don't get, let's say, this whole scripting language with Solidity, I guess. Is there,
Yeah.
by the way, do you envision a way to, because when you think about like DeFi stuff, a lot of projects just simply want to fork existing open source code, yeah?
Yeah.
Now, would it be possible, I'm sure it's not a priority at this point, but just in general, to essentially port code from a Ethereum smart contract over into whatever Rust, so you then get certain benefits? And
there are literally currently in the demo folder in the WASP repository, there are the ERC20 and ERC721 contracts that I ported to all three languages actually. So you have examples of how that is done. We need a few more features to be able to do everything that can be done. Like we need to have interfaces and inheritance to be able to completely support a similar system. But that's on the to-do list for after I'm done with the creating the client-side code. The EVM will support simply copying stuff, of course, but the problem with EVM is that it does not support everything that the ISCP supports itself. The Tangle is such a different beast. We're going to be running smart contracts in parallel, which is a trick that Ethereum cannot do. Right? In Ethereum, everything is a single chain that runs as a single humongous computer, essentially. In the Iota system, we have parallel chains where we can, for example, you could have a set of nodes for each token that you create, and each token could live in its own space separately, and they can still interact and trade with each other, but it runs in parallel instead of sequentially. And that means that it's a trick that you cannot do from within the EVM. That's something that is very specific to Iota, and we're going to have other features that are not easily supported by the EVM. If we're going to have the tokenization framework up and running, that is going to give us all kinds of functionality at the Tangle level, at level 1, whereas that functionality is usually simulated in Ethereum and other blockchains on level 2, because they cannot support it on level 1. And that means that things will start to work kind of differently. For example, if you have an ERC contract, the tokens that are generated by ERC20 are governed by the ERC20 contract itself. But if we can create tokens on the Tangle, then those tokens can be sent between people's wallets without the contract knowing about it, because they are full-fledged citizens on the Tangle. And so the whole way of dealing with those tokens is going to be different. We have a possibility of exchanging tokens from different chains in a secure way, completely secure, in a non-trusted way. So, or actually, it is trusted, because you can exchange on the Tangle. It's all anchored on level 1 in the Tangle, and so you don't need an intermediate party that takes one token and that takes the other token and swaps them and sends them to the correct person. That is all done by a smart contract that we can define on the Tangle itself. So there's all kinds of features. Those are just a few examples that gives Iota some leverage, but you cannot do that easily without expanding the EVM somehow. And if you're going to expand the EVM, you're not 100% compatible with the rest of the EVMs anymore. So there's a whole lot of stuff that you have to look into there. And that's why we have a separate system that supports everything that we support on the Iota Tangle.
That's very good. Very good. I like it. And one thing that I wonder, some people say, hey, let's use a Ethereum proven smart contract, if you wish, that has been tested. So if you then convert it into Rust or whatever, is that conversion a potential security risk? Because or is
that's always the case, of course. You need to be able to trust the software, right? We're having a few steps. The Ethereum VM is interpreting the Solidity code, essentially. And so you can read the Solidity code and see exactly what it does. And that is what is being run by the Ethereum VM. What we have is that we have source code. We have a library that is being linked, which is called wasmlib. That provides the interface to the system. We have several different compilers that are involved, and each can have different versions over time, right? So essentially, the resulting WASM code can change because one of those components can change. If we add stuff to the wasmlib, then that gets compiled into the smart contracts, and you get a different kind of smart contract. So what we still need to define is a tool chain that is verifiable, so that you know that what went in there and exactly what versions of what tools have been used in building the WASM code, and then you can build that yourself and verify it against the WASM code, which has a certain hash, and see if that one is resulting in the same code, so that nobody has tampered with it. But you have similar problems on the side of Ethereum. But yeah, they're more centralized in that regard, and therefore it's easier to control those issues.
Good, thank you.
Okay. So I'm going to increase speed a bit because we only had one image yet. So how does it work when we're loading a WASM smart contract? Essentially what we're doing is we're following this diagram. We're starting what we call a chain. It's essentially a blockchain. Even though we're running stuff in parallel, every parallel chain is a blockchain that runs sequentially. Therefore, we know what the order of events within a chain is. That is very important for a smart contract. That every smart contract needs to run deterministically. You need to know exactly what happens at any time. So we start a chain. The chain is consisting of, well, it's running on a group of nodes that will keep an eye on the consensus part of the chain. But for us, we don't really care much about that. That's in that regard, we're more users. We just trust that the whole consensus thing is handled by the WASP nodes. And what we do is purely focus on the smart contract itself. So in a chain, we can have multiple smart contracts that interact with each other. And there's also a way to interact between chains and send messages between contracts. So for now, we focus on a single contract. So we start a chain, we upload the contract, which is the WASM code that we generated from the smart contract code on the previous page. And then we tell the system to deploy the contract. So there's a separate stage. One is uploading it into one of the core contracts of the WASM node. It's called the Blob Contract because it's a blob of data that we send it. And until you start running it, nobody has any idea what kind of blob it is. It's only when you deploy it to a certain virtual machine that it starts to make sense of the data. So in this case, we will tell that it is a WASM time contract. WASM time is the WASM virtual machine that we are using. And what it will do is it will tell WASM time to load the WASM code from the Blob contract. We tell it exactly how to find it. Then it will link that WASM code to the sandbox environment. That's part. Like I said previously, WASM only can run that stuff that we allow it to run. And so we provide it with access functions that it can use to access the state. We provide it with details about the tokens that have been transferred. The WASM code can send directives to the sandbox to transfer tokens from the smart contract somewhere else. But it's all very tightly controlled by the sandbox and double checked that nothing untoward can happen. So if you have a view function, you're completely unable, even if you try to bypass it, to modify anything because you simply don't have the rights, and the WASP node will keep you from doing that as well. So that's where you link up the WASM code. That essentially consists of linking up two functions. That is because we needed this process to be fast, because every time you do a function call, you have to instantiate the WASM code. It needs to start with a fresh copy, essentially, so that you are completely deterministic. If you wouldn't do that, then certain global variables could have been modified, and then the next time you run a function, it behaves totally different. We can't have that, so to prevent people from trying that, we instantiate a new WASM code blob every time a function is called. So the linking needs to be as fast as possible, and I managed to funnel everything in the interface through two access functions, one to get and one to set data. and that in turn then passes it on to the sandbox functionality that is available. So it's first kind of encoded, funneled through those two functions, and then on the other side decoded, and then dispatched to the functions that they are meant for. One of the other things that happens during deployment is that the onload function of the smart contract is being called, and this function describes the contract to the WASM VM. It needs to know exactly what functions can be called and how to call them. And so what has been generated by the Schema tool is a piece of code that is a hard-coded data structure, a global data structure in the smart contract. So the contract itself doesn't need to build it, it's already there. And then there's a one-time initiation of the onload function that will tell the system what functions there are and how to call them. And then after that, the system remembers that. So the next time the WASM code is instantiated, it doesn't need to call the onload function again. So again, it's trying to optimize the startup time for the WASM code. Then once the contract is deployed, normally the first time it's run, there is an init function being called. That is the next thing. And after that, it's ready for function requests, and those are being handled here. But the init and the function requests are actually handled in exactly the same way. Init is just a function that can be called only once at startup by the system and by no one else, and that will initialize your smart contract state. Function requests, and also therefore the init function, are initiated by the onCall function. So we call the onCall function in the WASM code with the correct parameters that we decide upon from what we got from the onload function earlier. So we know how to call the function, and this has turned the function call into a simple call with a single ID. So again, it's all very fast and easy to determine and easy to call, so that it's not much overhead to call a function. And what happens then is that we're going back to the WASM time again, because then the WASM code is being triggered, the onCall is being called, and the onCall uses its internal data structure to find that function ID that the onCall function passed it, finds the function that is associated with it, and then it calls what I call a Thunk function. A Thunk function is kind of a wrapper function around the user function that you want to call, that does a bunch of things automatically for the user. So for example, it will check parameters, it will check the access, it will set up all kinds of data structures that are necessary, etc. So this Thunk function then will retrieve function parameters from the system. So function parameters are not passed at the moment of calling, but are simply remembered by the system. And then at some point, the WASM function will initiate a call to the system and say, okay, give me the function parameters. And those are a simple key value map that then can be processed by the function. It also creates what we call a function context that specifies to the WASM code what kind of context it is running in. And that is something that I will explain a bit more later. Then it will call the actual user function. The user function is the part that the user himself has created. Then the user can do whatever he wants based on those parameters and the fact that the function has been called. And the user will potentially update the state, will potentially set results, and potentially return those results. And those results are returned to the system for whoever called this function. For example, if you called a view to get the percentage, interest percentage of your smart contract, then this is where the interest percentage is being returned. As a map, it's returned to the system, and then the system will make sure that that map gets to wherever the caller was, because you don't know in the smart contract who or where the caller is. The system knows that. So let's go to the next image, which kind of describes this in a slightly different way. Smart contract function requests come in. They are passed to the Thunk function. The Thunk function, it's smart contract functions come in on the WASP node side. So we have the WASM side on this end, and we have the WASP node side on this end. Smart contract function comes in. That can be through a request on the Tangle, but it could be an offline request. It could also be that smart contracts are sending each other requests. Anyhow, the system makes sure that the requests are ordered in the right order. One of the function is going to be the first to be called. That function is being called, and on the other end, what will happen is that it will retrieve the parameters into the WASM side of the code through what we call a proxy that has been handled by the Schema Tool's data structures that have been generated. So the code knows how to do that and what types there are in the parameters and in the results and in the state and everything, and generates code that through proxies can access the values in those containers. So this is the parameter container that is being transferred as a whole to the other side. We also have the state container, but the state container lives in the ISCP sandbox. And the only thing we can do is we can write to and we can access from it, but we are not going to completely copy it to the other side because it could be ridiculously big. So all we copy is the data that we want to access. So that's why we call this a proxy interface. It can access with local containers, data containers, but it can also interface with external data containers, and it looks exactly the same to the system. So it makes for a very easy programming interface. Then we have another proxy to the results. While the function is running, those functions can update the results, and once the entire function is completed, that entire result container is sending its data to the result container on the other side in the WASP node, and that's where it then gets passed on to whoever called it. So we have from the WASM side, we can do calls to the sandbox, and those sandbox calls again are passed on to the other side. The WASP node will then process the request and return any data back to the call function, and that one can process it. So that's essentially, in a nutshell, what a smart contract looks like and what it does. Are there any questions there?
No, but I gotta say, that's amazing how well you explained all that, and the graphs work. I'm impressed. Nicely done. You hadn't done this before, right? These are new drawings. Wow.
These are new drawings. Yeah. So
it sounds like you rehearsed it a million times. Really good.
No, yeah, well, in my head maybe, but that's because I'm constantly explaining it to myself.
Nicely done.
So here's the last image, and then I won't talk your ears off anymore. So what we have.
By the way, Eric, I know that you also have a life, but as far as I'm concerned, this is very well spent time, yeah. And if somebody has to watch television or bring the kids to bed or whatever it might be, can drop off, yeah.
Yeah, they can always watch it back if they want to, and if they're not really the programming type and do not care for the details, then of course.
Well, even I think you've done it good for people that are, not really programming types. I mean, you explained it in such a good flow. Yeah, nicely done.
So then the final image, let's quickly handle that. It's not a difficult image. So we have the schema definition file, we have the schema tool, the schema definition plus the schema tool will end up in smart contract code, either in Go, in Rust, or in TypeScript. And we have for each of these, we have the wasmlib implemented in that language. So that the smart contract code can interact with the wasmlib, and the wasmlib knows how to interact with the node, right? So there is if you create Go code, you can use the the Go wasmlib version. If you create Rust code, then you can use the Rust wasmlib version, and they're essentially identical. If you look at the code, if you understand one of the languages, you can definitely read the code for the other languages, because I'm trying to use the least common subset of programming constructs as much as possible, so that it stays clear, not only for me, but also for other people. And the same thing goes for the wasmlib, because the wasm code cannot do much by itself. That means that everything contained in wasmlib needs to do the same exact thing. And because we're using the same exact structures in different languages, it looks exactly the same in those different languages. If you put source files next to each other, you will see like, crap, that's exactly the same, and I can actually understand that is the same, right? Even if you're not a programmer. So anyway, the smart contract code and the wasmlib together are an entity. That is the wasm code essentially, but it does not work yet without a context. And this is where it gets interesting. So normally we can be calling contracts from within other contracts using this code, for example. And what we then have is a function context or a view context. Oh, there's a typo there. This is part of the code that interacts with the Iota smart contract sandbox. And then if you have this plus that context, that results in smart contract requests. So we also have the smart contract code and the wasmlib, but now we use a different context. So the context is literally an object you can pass into your program that is passed to the smart contract code and the wasmlib code together. The context, in this case, the solo context, allows you to use the exact same code to test your smart contract. So if you want to test your smart contract, you generate, you type the code as if you are creating a call from within your smart contract. It's done in the exact same way. Therefore, you don't have to do, well, in this case, it is a context switch, but the context switch happens transparently behind the scenes. So the way you program a contract call within a smart contract needs a function or a view context, and then you can do smart contract requests. But if you do it with a solo context, then you can do solo debugging and create unit tests in solo. That means that you are able, the solo system will allow you to run smart contracts, but they are run in a very deterministic way. Even if you send a request to another smart contract, that request is immediately executed. So you know deterministically what just happened. You don't have to wait for it to happen. And therefore, it is very easy to write unit tests in solo. So programming solo happens in the exact same way. And while I was doing the conversion for Stardust, some quarter fell because I was seeing the same kind of things that I needed to do in the client-side code that I needed to do in either solo or in smart contract programming itself. So even though initially my code generation, the schema tool was generating different code for the client side code, I have now defined a client context, and that means that I can use everything from the smart contract and the wasm-lib on the client side as well. And so if you are calling the smart contract through the web API on the client side, that even looks exactly the same as when you call a smart contract in Solo or within your smart contract. So this code, this blue and the green box, is always the same. You simply pass a different context to it, and then it will behave differently. It will either do smart contracts in the WASM node, or it will do the smart contract stuff on the Solo system, or it will call the smart contract web API through the client side. So this means that you don't have to learn new things anymore. You can learn it once and you can reuse it in all three purple boxes. And that is something that is, I think, is going to be pretty unique in the ecosystem. I don't think we have any comparable tools in any chain that can do stuff like this.
Yeah, I don't know. I don't know if others, maybe somebody else does, but that is really impressive. I mean, I know you've been cooking this for a while, but this last iteration was really awesome that you're able to do that for all three of them. So
yeah, and it makes my life easier because I only have to generate code once. Instead of having to generate separate client code, I now simply reuse the contract code that I already generated. The client-side code wasn't ready yet because I still had a bunch of corners and nooks and crannies where I needed to generate the code, and I didn't do that yet. We were missing the structured data types. We were missing the type defs. It was only a bare bones system. But now that I'm doing this with the client context, all of a sudden, all that functionality that was already there and debugged and well in the client side or in the host side and in the Solo side is now also available for the client itself. And that means that, for example, the schema file defines parameters and return value types, etc. And it goes so far that you can have those virtual containers on your results. So I could define that the result returns an array of structured data. And you need to know how to decode that array. Well, guess what? The code that I generated knows exactly how to decode that and will do it for you. So where you do it, whether it's in Solo on the client side or on the host side, doesn't matter. You can simply start using it. You don't have to deal with the decoding. You don't have to deal with the transport layers. You don't have to deal with, or hardly have to deal with, setting up the client side because it uses a lot of sensible defaults. So it's going to be, if you originally looked at the Fair Roulette demo contract that we have, then the smart contract itself is pretty simple and straightforward. And then you have an enormous amount of code that implements the client side.
Yeah.
That is going to be almost completely hidden from the layer where you call the smart contract and everything below it. So the entire layer that does the HTTP get and puts and sends commands to the proper web API entry points and encodes it in JSON and decodes the results into structures. That is all hidden now for you. So you simply get your data. You tell the contract, I want X, and the contract gives you back X. And in your interface, that's all you do and have to do. And then you can just put it on your screen or whatever you do in your client side with it.
That is freaking awesome.
Yeah.
That is
so that's in a nutshell what I'm working on at the moment. And you can tell from my enthusiasm, I'm having a lot of fun.
Yeah. What a slacker you are. Amazing. I don't know. I'm impressed. Wow, you covered a lot of
So,
ground. Great pictures too.
Any questions about this?
No, I'm excited as a person who has no technical ability. This was really insightful. I'm excited to see the recording of this over and over again.
Yeah, it is recorded. Yeah, so that was. It'll be good to. I mean, I'll definitely need to review it because you covered so much, but your explanations of everything were completely understandable, and I loved it. Really
Cool.
good job.
Mission accomplished.
Yeah, you really did.
Master's degree class for the next 2 years in the future.
No kidding, right? That is really true. I mean, you covered so many areas in each one of those, and you also basically explained a lot of the context of what people normally may not understand. So you did such a great job on this. And just to think, you whipped this up today, right?
Well, this was a off-the-cuff presentation.
Yeah.
The three of the 4 images I created today, and well, the order and the talking was just. If I'm going to have to do this presentation again, it will probably be completely different.
Well, this one's a good one. I think if you listen to the recording, you'll be kind of going, "Wow, I did really well on this one. I got to remember how I did that." I think you did great.
You know, I've never watched back any of my recordings. I don't have time for that shit.
Well, I think it was just great, and thank you for coming in at the last minute. I mean, it's kind of amazing that you were able to do this well with this.
So one more note about this stuff. So I just yesterday got that client context working for the Go version, and so my next step will be to create the client context for the TypeScript version, and then it will appear first on the current develop branch, and then I will take a few days probably to backport all that client code into the Stardust repository so that it works on both ends. And so I'm estimating about up to 2 weeks work left for that to all be completely available.
And you said that was TypeScript?
Then we have the TypeScript version as well. And then what's missing is the Rust version. I haven't done the Rust client-side code yet, but that should be relatively easy, or even I could maybe farm it out to somebody else because the outline is there, right? So you just have to follow the system.
And then it's a universe of smart contracts.
Yeah, really is. I'm thoroughly impressed. Nicely done.
Okay.
Anybody else got anything else? Been a good hour and a half, so I think I'll give you guys back your evening. Thank you so much, Eric, and thank you, JD, Deep Sea, for the earlier overview of what we're doing with the Bridge Fund concept. And we'll sign off, and thanks, everybody. We'll catch you in 2 weeks.
I have a question, sorry.
Oh, sure.
Yeah, I thought that we had the final round for additional questions. So my first question is, it's kind of open about what other projects are doing regarding the minting of their own token. If they are looking first at Iota EVM minting, or betting on minting on Shimmer directly, and if it's just to see or hear experiences of how do they plan, or how do you plan, guys, to migrate from one to the other?
Is someone for Sunaverse here or from Iota bots that could like tell us if they are planning to do it on Shimmer or on Iota EVM and in the testnet right now?
Well, I'm from Cineverse. So the question is repeat the question for me, please?
Yeah, so if for the minting of the Sun token, are you planning to use Iota EVM or Shimmer Network? It might be an NDA type of question.
Yeah,
Like
yeah. I probably
say
can't go there.
EVM
Yeah.
in the end, but the Iota EVM, like there will be two Iota EVMs in the end, like the ones in Go Shimmer or the ones in Shimmer, or maybe in Rinkeby testnet, or maybe on a different EVM.
Yeah, I want to defer to. I'll defer to Adam. So
Yeah,
I can't answer that now.
Yeah, I
I'll
would say
text you.
right now,
Yeah.
let's we're not going to answer that question now, and after we get a little further on, we'll probably be able to answer that. I think that's just the safer answer. So
Yeah,
we would like to and really like to, but I think there's just some reasons why we can't do that right now.
Yeah, yeah.
And we apologize.
No, it's okay. Yeah, we have the same question. It's like what to do, right? Then I guess Oliver, can you ask the other question about the nodes for Iota EVM, which is sort of related to, but it's more technical.
What was the question?
The nodes of Iota EVM, that there are only 2 nodes running, I think, for the chain. And yeah.
I don't understand the question. Sorry.
Let me see. I have a note here. Yeah, we were checking the Iota EVM nodes, and well, it's obviously for testing, right? So we have only few nodes, and these are being restarted very often.
yeah. We had a lot of issues today. Yeah.
Okay, so you are using those nodes for the minting. So there is like the question was if someone else is running a parallel network, or we are on the same boat using Iota EVM.
Well, the issues we were having with EVM was just for people logging in, and so and that was inconsistent today. We had a lot of times where it was unavailable. So
yeah,
and
I think everyone
Shimmer?
that's kind of facing the same issue. I think I answered someone that today in Discord asked that question. I mean, right now everything's in a testnet state, so you have to be, kind of careful. There's some people that are running their own EVM chains, and Iota EVM chain is one of those. So hopefully, I think we're all looking for ShimmerNet and to have a bit more nodes out there to rely upon, something that's a little more stable. But I think we all have to kind of deal with the current situation for a bit longer. I think that's how I answered it.
Yeah. Okay. Yeah, just want to know. And the last question is more for programming. If maybe Eric have worked with WebSocket and actors in Rust, we're trying to obtain the messages that arrive from the WebSocket client from a function, let's call it function B, as a callback to let us know with a message to the function A. This is for the auction feature that we are building. And it's, I think, the only constraint we have so far right now for the backend to make it work the way we want it.
I'm afraid I don't know yet, because, like I said, I need to start on the Rust client-side code, and that means I haven't looked at how Rust does HTTP requests and such. The first thing that I will build is the wrapper layer, and underneath that it will use whatever libraries are available to do HTTP requests, and I'm not sure about that. And we also have to deal with the event handling, which is a different kind of WebSocket listening, right?
Eric, if you can stub that, there's Rust developers on this line that are happy to help do the HTTP client requests in Rust. I do that all day, every day.
That's exactly what I meant earlier when I said if I could offload some of that to someone else, I give them the layout and the framework. This is what I have, and this is what needs to be done underneath. But I'm not a Rust developer, so I don't know which crates to use or which are good or whatever, right? I'm going to have to learn all that. So it might as well be done by somebody who knows what he's doing, and then he can laugh about the code that I generate because that doesn't look like Rust at all. But well, I'm very simple about that. It works.
Yeah, if you stub the signatures and just what you want to have achieved, and say point to what to go in the TypeScript library client code, then I can fill it in.
Okay, that's a good thing to know. I'm first going to have to finish the TypeScript site and then compare the Go and TypeScript versions so that I have a good grasp on what different languages might require, and then build the Go access layer under which all the HTTP requests and such have to be handled.
I'm sorry, who was it that was speaking that said they could help Eric?
This is Scott or Tudman.
Oh, yeah, Tudman. Cool. Okay, cool.
Cool.
I was about to write you a message, Tutman. So is that WebSocket and Rust callback function that something that you can at least give us some extra eyes on?
If Eric, you'd be so gracious as to just stub the signatures or just write pseudocode of what you need to have happen, then I can write HTTP client code in Rust. That's what I do all day, every day.
Cool. Well, it will be even better. You don't have pseudocode. You will have actual code in Go and in TypeScript to see what is necessary.
Yeah, I can do a comparison.
Yeah. So yeah, cool.
Awesome.
I love it.
Hey, well, those last minute questions actually produce tangible results. Very awesome. Gotta love that.
And where's the recording going to be posted, please?
It'll be in the Americas, Iota Americas channel on YouTube. Probably be there tomorrow.
Sweet,
maybe
appreciate it.
Tomorrow afternoon. You bet. Gotta let some time for Dave to be able to get some dinner now. So let him. So, all right. With that, I think we'll kind of wrap it up. Very good. Okay. So thank you, Dave, for doing the recording and all that, and thank you, Eric, for amazing job, and everybody else for the questions. And we'll see you in a couple weeks.
Okie doke.
All right.
Thank
take
you,
care.
guys.
Bye bye.
Bye bye.
Thanks, Frank.
You bet. Thanks.
Thanks.